It's trapped deep beneath the Earth's crust, and for half a century it's helped fuel mankind's insatiable appetite for growth.
Modern society would struggle to function without it. I am, of course, talking about black gold, oil.
Today we're focusing on oil. What is it, where is it, and what's it used for? And perhaps most importantly, how can it be used more sustainably?
Lots of questions there that we will answer. But first, did you know that oil has been a source of energy since ancient times? Unrefined oil was used before the Industrial Revolution. In fact, it's thought that oil has been a source of heat and light energy for thousands of years.
But it was in the 19th century that advanced drilling and refining techniques made oil available on a mass scale. It's impossible to overestimate the importance of oil in the development of human civilization, and it's quite extraordinary to think that something created so long ago remains absolutely crucial to our everyday lives, even today. Afia, you've been very busy with this topic. What's coming up in the programme?
Ahead on today's show. Many heads are better than one. We take a look at the environmental benefits of collaboration in Canada's oil sands industry. Underwater robotic snakes. Sounds like something out of science fiction, but they're real, and they're making oil exploration more environmentally friendly. Plus, we visit a refinery with a difference in Brazil to find out how you can extend life of your used car engine oil. And finally, the alchemy of oil. Can we really turn waste plastic into liquid fuel?
As usual, we'll be joined by our sector expert to hopefully answer all of our questions. But first, some basics.
Oil is the world's primary fuel. Worldwide, we consume more than 90 million barrels of oil per day. That's 35 billion barrels a year. Members of the Organization of Petroleum Exporting Countries, OPEC, produce around 43% of the world's crude oil. Traditionally, we just drilled into the ground and hit black gold. But now extraction is varied. There's deep sea drilling, fracking, and tar sands.
From satellites monitoring emissions to amphibious vehicles, we travel to Alberta to see what happens when people work together. In unity there is strength, so says the proverb. Dan Wicklum agrees. As the Chief Executive of Canada's Oil Sands Innovation Alliance, better known as COSIA, he believes that the industry can only be sustainable if it works together.
We have 10 members that account for about 90% of the daily oil sands production in Canada. And it was launched by the most senior leaders of these companies, the CEOs, as a sign of a personal commitment and a commitment of their companies to work together to accelerate environmental performance improvement.
Alberta's oil sands are a massive source of bitumen, a material which can be processed into crude oil and other petrochemical products. There's an estimated 165 billion recoverable barrels of oil here, but extracting it can pose risks to the environment. Under pressure to decrease their environmental footprint, COSIA members are focusing on 4 priority areas: water, land, greenhouse gases and tailings, a fancy name for the leftovers from the mining and extraction process. In very simple terms, members are pooling ideas.
To date, the COSIA members have shared about 938 discrete individual technologies or innovations that cost about $1.33 billion to develop. We set a goal in 2012 to reduce our freshwater use intensity by 50% by 2022. And since 2012, the companies have reduced their freshwater use by 38%.
The environment benefits and so do company budgets. By collaborating, oil sands firm Synovus says individual groups don't have to reinvent the wheel.
A fundamental principle for our operations is to collaborate with other companies. We're trying to turn CO2 into valuable products and help solve climate change. We want to leverage their resources, we want to leverage their bright minds, and we really believe that that's going to enable us to develop technologies quicker, faster, more efficiently.
One of the main issues with oil sands is that the extraction is carbon intensive. The Alliance is working on reducing greenhouse gas emissions and is looking into whether satellite technology can gather more accurate emissions data.
One of the things that the COSIA companies have done is they've launched their own satellite, GHG-SAT. They call it CLARE. It's about the size of a microwave, and it circles the Earth, goes over that oil sands region about once every 2 weeks. And because we have Claire measuring, we can get more accurate measurements, we can get more frequent measurements, so that the companies know that the technologies that they're implementing for GHG reduction, whether they're working as well or in some cases even better than they had thought.
Back Down to Earth and the Alliance has launched an ambitious CO2 challenge.
Another example of a COSIA project is our NRG COSIA Carbon X Prize, where we've partnered with an energy company in the United States called NRG. So we're offering $20 million to the team that can best take carbon and turn it into a valuable product.
Dan believes it's not absurd to imagine a future where oil extraction is carbon neutral.
Our expert for this episode is Gioia Falcone, Professor and Head of Oil and Gas Engineering Centre at Cranfield University in the UK. She has an MSc in Petroleum Engineering from Imperial College London. She was appointed leader of the International Geothermal Association in 2009.
Gioia, thank you so much for hosting us here at Cranfield University. You have an illustrious career in the oil and gas industry. Can you tell us a little bit about what it is that you do here?
Thank you. I'm Professor and Head of the Oil and Gas Engineering Centre here at Cranfield University. I deal with research and teaching activities in the fields of oil and gas as well as renewable energy.
Well, obviously we want to talk about renewable energy, and historically oil has a high profile when it comes to pollution. Can you tell us a little bit about whether oil can ever be truly green?
It's very true, the oil industry has a very high profile when it comes to pollution. Can it be green? Can it be regarded as greener? I definitely think so, and the oil companies are already transitioning into broader investment into renewable energy resources as well as oil and gas. So maybe in the not so distant future we will refer to them as two energy companies.
As opposed to just oil companies?
I think so, yes.
Maybe you can tell us, you mentioned greener. Can you tell us some of the technologies that are being invested in to make it more of a transitional fuel?
Several oil companies have already started to invest in geothermal energy projects, wind energy projects, solar energy projects, and they're already making big investments. We're talking about deals in the range of probably $1 billion each. There have been initiatives such as the Oil and Gas Climate Initiative, putting together 10 major companies committing to $1 billion investment for the next decade.
Can you tell us about some of the technology with underwater robots, for example, on prevention and cure of oil spills?
Certainly this underwater technology is key. We have been using remotely operated vehicles, ROVs as we call them, for several years in the oil and gas industry. They are there to allow us to monitor operations in areas where you couldn't really go as humans. And also you can do interventions directly to stop these spills, and that's precisely what has been done for Macondo.
Well, we'll be hearing lots more from Gioia throughout the rest of the programme, of course. But a lot of us may think we know about the oil industry. If you do, think again, because here's one common misconception.
You thought you knew? Think again. Myth. Renewable energy sources will soon render oil obsolete. Fact. Renewable energy may reduce the need for oil, but petroleum will be required for decades to come. Apart from history showing us it can take generations to transition to new energy sources, oil's use extends far further than energy. Oil products are found in almost everything you come into contact with, from takeaway coffee cups to clothing. Oil is, quite literally, everywhere. Oil prices have halved over the last decade, so when it comes to oil exploration, improving efficiency is a top priority. We take a trip to Norway to see how that can have trickle-down benefits for the environment.
Currently there is a gripper tool in the front of the vehicle, which the robot can use to grab hold of objects.
In this test tank in Trondheim, Norway, there's some pretty innovative work going on. Paul is co-founder and Chief Technology Officer of Elum, a Norwegian underwater robotics company. Set up 2 years ago following a decade of research, it's a spin-off from the Norwegian University of Science and Technology. Elum has developed a groundbreaking system that repairs and does maintenance on subsea oil installations. The company hopes that snake robots will replace slow and costly surface vessels, making maintenance safer, cheaper and greener.
Traditionally, they have used remotely operated vehicle controlled from a surface vessel. And that is a very costly method because the surface vessel costs a lot of money and you have a lot of people on board. Our vehicle is permanently installed on the seafloor, so we don't need to engage the surface vessel to do inspection and maintenance work. That reduces the CO2 emission.
With sustained lower oil prices, companies are feeling the pressure to find greater efficiency measures. And when it comes to maintenance, Elum thinks that its robotic-like arms are the answer.
The Elum vehicles are ideal for carrying out inspection and maintenance operations in tight spaces not accessible by larger, more conventional underwater vehicles. They can also carry out more typical intervention tasks such as operating valves and removing marine growth. They can also carry out very energy efficient transit over long distances since they can move like a torpedo underwater, and they are also designed to live underwater by the subsea installations for long periods of time, such as weeks and months, without requiring a human intervention and maintenance.
Elum says the robot can carry out repairs with the same dexterity as a human hand.
We are currently designing a new prototype with a depth rating of 500 meters, which will also be able to carry different types of tools and carry out different types of intervention. And the vehicle will actually have tooling in each end, so it will actually be able to grab hold of something with one end and carry out the tool operation with another end. It will also be able to provide a very good view of the situation to the topside operator, since we will have cameras in each end of the vehicle.
Developing this type of technology doesn't come without challenges.
Even though our vehicle is flexible with multiple motorized joints, we still have a highly durable and robust design due to our solution for the articulation based on covering each mechanical joint by a bellows, which is filled with oil to handle the pressure underwater.
But overcoming challenges is all part of, well, the challenge.
We have developed our concept at quite a high speed, going from a concept to a real prototype, and we get good feedback from the major oil and gas players in the industry, so it is very promising.
Joy, we've just been hearing from Norway a little bit about exploration, and there's talk of 2050 being a date for peak oil. Can you explain to us what peak oil means?
Peak oil is a term that covers a bit of uncertainty in my opinion. For a start, I could say that when we say peak oil, oil actually includes gas as well. We tend to convert the gas volumes into barrels of oil equivalent and then put everything together in that magic number that people call peak oil. In a way, I believe and I don't believe in peak oil. I do believe in what we call the reserves replacement ratio. It's basically the ratio between the new reserves which are added to a company's portfolio and the production from the company in a given year. As we keep depleting the existing reserves, we have potentially less left unless we replenish that number with new discoveries. Advances in drilling technology in the oil industry have already allowed the industry to untap resources which before were considered as unachievable. I could mention, for example, horizontal drilling, I could mention monobore drilling, I could mention casing drilling, I could also mention geosteering, which allows you to go deviated down underground. And we've reached records. For example, in this very same country, in the UK, there was a record for the longest horizontal extended reach drilling in the Witch Farm field in Dorset, with a horizontal section of 10 kilometers.
When we think about horizontal drilling, a lot of people think of it as new technology, but I know that it's not really, is it?
Correct. It's not new technology, it has been used before, but we hear more about it these days in relation to the unconventional resources, which indeed do require horizontal drilling technology to be exploited.
Fracking uses a lot of water. What's the industry doing to reduce water usage to make it more sustainable in the long term?
Hydraulic stimulation does require the use of water, and we have a large number of wells to be drilled in unconventional resources which require this technology. The industry is already responding by trying to be more efficient in the way they perform these stimulation jobs, trying to use less water as much as possible, and also trying to recycle the water. It's a closed loop system. Of course, some of the water gets lost underground, but the majority of it does return to surface and can be treated. Also, we are looking into alternative fluids.
In our next film, we're going to be thinking about the reuse of oil. What can you tell us about the technologies from extraction all the way to utilisation to make the process more environmentally friendly?
Environmentally friendly has to do with improved efficiency and recycling. We can improve the efficiency of drilling the wells, producing hydrocarbons from those wells. We can improve the efficiency of the process of treating the produced fluids, and we can think about recycling, such as waste oil recycling.
Coming up after the break, as good as new, we visit a refinery in Brazil that's breathing new life into used engine oil. And we travel to Shanghai to see scientists working their magic, transforming plastic bottles into fuel.
The words oil and renewable make strange bedfellows, but in Brazil they're really quite comfortable together. That's because there's growing interest in a process that re-refines used car engine oil so efficiently that the end product can be even better than its original form. We travelled to Sao Paulo to find out more. Combustion engine vehicles. There's more than 1 billion of them traversing our roads, and they are all thirsty for fuel and oil. Indeed, without lubricant oil, these machines would seize up in a matter of minutes. Here in Brazil, traditionally one of the world's top automotive markets, more than 2 million new vehicles will be sold this year, despite the ongoing recession. Demand for vehicular oil products isn't going to go away anytime soon. Here at the Luarte refinery plant in Lençóis Paulista, in the state of Sao Paulo, there are efforts to make the car industry a little cleaner.
Luarte collects used oil all over Brazil in thousands of locations, service stations, quick lubes, factories, agriculture, mining. Last year we processed 140,000 metric tons of used oil.
Under Brazilian law, all used vehicle oil must be re-refined. It's part of government plans to try and limit dependence on imported oil, whilst also protecting the environment. It's far from perfect, but the system is improving.
The most common destination for used oil when it's not re-refined is burning it as a fuel. In our view, at this moment when everybody's looking for cleaner energy sources, cleaner fuels, it does not make sense to burn used oil, which is not a clean fuel. Re-refining is the best solution for the environment.
The technology used by Luarte is provided by American firm Chemical Engineering Partners Incorporated. The idea was first developed 3 decades ago, and the company has been perfecting the process ever since.
Since its first use 30 years ago, we have improved our technology significantly. Our technology is a renewable process where we re-refine used oil and bring it back to a quality that's same or better than its original use. And one of the most significant improvements is such that we are able to produce API Group 2 base oil from all kinds of oil.
Here in the laboratory, technicians are constantly testing the lubricant oil's quality. The process to re-refine the oil is known as hydrotreating.
The re-refining process is divided into sections, front end and back end. Front end, the idea is to remove all the contaminants, the water, the light ends and the asphalt, and to collect what we call lube distillate. The lube distillate is sent to back end, where we have the hydrogen acting to remove all the sulfur and the double bonds that we call unsaturation. The result for the process is a very good quality oil that has low sulfur and high saturates.
Car ownership is increasing throughout the world, most notably in emerging economies. The company's technology is particularly important in countries where second-hand, cheaper and older vehicles are flooding the markets.
Many developing countries are licensing our technology as well, because it helps them to reduce the dependence of foreign oil import. At the same time, it also helps those developing countries to control their environmental impacts of burning or wasting used oil.
Solutions like these can play a tremendous role in reducing greenhouse gas emissions and protecting the environment. Indeed, they must. Our dependence on our four-wheeled friends is unlikely to slow down anytime soon. Modern humans need it, but let's face it, the environment could do without it. Plastic. It's everywhere, it's polluting ecosystems, and it's blighting landscapes. We visit Shanghai, where scientists believe they're getting closer to turning plastic waste into a fuel of the future. It's fair to say that humans have a love-hate relationship with plastic. We're becoming more intolerant of it, whilst at the same time we're using it more and more. The World Economic Forum says there'll be more plastic than fish in the oceans by 2050. But imagine a future where we no longer see it as a plastic plague of sorts, but instead a source of energy. That isn't such an absurd idea when you consider plastic is derived from oil.
If we have the plastic waste in the environment or in the ocean or bury it underground, it's going to stay there for hundreds or thousands of years. So we need to find a solution to the plastic waste, and we think converting them into fuel is an excellent way to reuse it.
Polyethylene is used to produce everything from food packaging to shopping bags to plastic bottles. And with an estimated 100 million tonnes of it produced annually, it seems like a pretty good idea to do something with it.
So what we are doing differently is to use a so-called cross-alkene metathesis strategies. The process involving the metathesis between polyethylene and shorter alkenes, which are very cheap and has low values. So the metathesis between the polyethylene and the shorter alkene will result in the breakdown of polyethylene into shorter alkenes, which are suitable for diesel fuels.
This isn't a new idea. Scientists have been trying to crack this process for half a century, but the team here think they may have made a breakthrough.
And this process needs a lower temperature compared to the conventional methods. It can degrade the polyethylene into relatively clean product under mild conditions.
The end product could be used for a variety of purposes.
In our process, we can get the oil hydrocarbons as the major products and some waxes as the minor products. The major products can be used as a fuel, such as diesel.
But with the recent price of oil at almost record lows, it's unclear if recycled plastic would be economically attractive.
At the early stage, we need to develop a method which can degrade plastic into useful product. But eventually, we need to develop a more efficient system which can make the process economically viable.
Despite criticism, the team are determined to pursue what they see as a solution to the bewildering levels of plastic waste.
So far our technology is limited to the degradation of polyethylene. So hopefully we can develop new methods for degrading polypropylene, polystyrene, and other type of plastic.
So Joy, we've thought about reuse and recycling within the oil industry. For you, is that where the focus should be in terms of sustainability?
Indeed, we've got to learn to be much more efficient in the way we do the business, and we have to think ahead and how oil can actually help in this transition towards a greener and more renewable world. We need to be careful in the way we use the reserves that we already know we have and try to use them more responsibly.
What do you think about the idea of local versus international, of modular systems in terms of sustainability within the oil industry?
This is a very crucial dilemma in the energy conversation, because we often hear governments taking the global approach, whereas in my view at least we should really focus on a local approach. We don't have the same energy resources everywhere in the world, and we also don't have the same accessibility to these resources wherever we are. So we have to think a little bit clever and try to find the best solution for one given location, one given situation.
As we've seen, efficiency and prices can have effect on the sustainability of the oil industry. What other solutions might there be?
Certainly thinking hybrid, so trying to integrate conventional energy resources with renewable energy resources, try to see the synergies between them and how we can use this process to stimulate even more research into renewable energy, to make the renewable energy exploitation more efficient.
And how do you see the future of oil in terms of the global energy mix?
Oil will continue playing a very key role in the energy panorama and in this transition towards renewables. Mix is the right word. Oil will be there for many years ahead and will have to be used wisely and will have to be used in such a way that we continue thinking more efficiently and thinking always in respect of the environment and thinking ahead about what oil can do to favour the uptake of the renewables.
Joy, it's been fascinating talking to you. Thank you so much and good luck with the rest of your research here at Cranfield University.
Thank you very much.
We've seen how indispensable oil has become to modern life, and we've seen the key role that oil will continue to play in our futures.
And with technology advancing at pace, all eyes are on the oil industry as it strives to become cleaner, greener and more sustainable. Hopefully we've answered some of your questions, and as always you can join the conversation on Twitter at CNBC Energy using the hashtags AskSE and Sustainable Energy.
So it's goodbye to oil, and next time we say hello to another energy source with unlimited potential, feared by some and revered by others, nuclear. Tweet us your questions and we'll ask our expert on the next episode of Sustainable Energy.
And until then, keep thinking green. Goodbye.
Goodbye.